We can generate some different signals on the board. We can generate DC levels, 2 different DC levels, and then 2 different sine waves, one at 1 kHz and one at 2 kHz, and you can set the amplitude of each one. And this is arranged so that these 2 boards simulate the transmitter, and those 2 boards simulate the receiver.
Have any of you actually used this before?
Yeah,
second year
for CD with Steve.
That's good to know.
Last year we had to do a phase shift.
Yeah.
Okay.
So if you've done phase shift keying, QPSK is the next step after that.
Okay.
I can't imagine it being too different. We'll find out.
So you remember that this is the postcode and pulse code modulator board. And then that one conditions it in the different shift keying that you use. Today it's some QPSK.
It's been
Yeah.
And we'll just connect the zeros together to get rid of earth loops. It probably works without it, but so we take the clock from this one to drive the clock of that board, and the output from here becomes the input to that board. You get a pulse at this point for every block, every byte. And so you can use that to synchronise the oscilloscope on the bytes when you look at the data that's being sent on the oscilloscope. This, for QPSK, we split the byte into even bits and odd bits. And the even bits come out there and the odd bits come out there. And then you process each one as you did for PSK.
Okay.
You put it through the unipolar to bipolar converter and then modulate that. But we've got 2 modulation signals, same frequency, but they're at 90 degrees apart. So we're getting 2 PSK signals modulated on carriers that are 90 degrees apart. So this modulator's modulating the most significant bits. Modulating most significant bits as QPSK. And then this one's modulating the least significant bit as QPSK on a carrier that is 90 degrees away from the most significant bit carrier.
Yeah.
Then you add those 2 together in the summer here. So that gives you your 4 phases of modulation.
Do you want to come round?
2 of them are
not being the
modulating the least significant bit and 2 modulating the most significant bit. And for demodulation in the receiver, you need to study these points in detail to see how it achieves the demodulation
This is
here.
for QPSK, right?
Yes,
Okay.
but you get 2 signals coming out of that called the I and the Q, which are very similar to the signal that came out of the PSK modulator. And if you remember what you did with the PSK, you had to low-pass filter it.
Yeah.
So put those 2 signals into the 2 low-pass filters. And then it had to be squared up So put it into a comparator. So that when it's higher than the reference voltage you get plus 5 volts out, and when it's lower than the reference voltage you get 0 volts out. So that's nearly back to digital here. And we then need to do the reverse of this logic circuit here to get back the original data that we had there. And that's done with this logic circuit here. But this logic circuit needs a clock, and we generate the clock on that board. But we need to generate it from some data. We can't generate it from the output of this because we're needing the clock to get it to give us an output. So we've got to go back before that to get the data that we generate the clock from. Then we can take the clock that's generated here and put it back into that circuit. Then that logic circuit will work and give us an output, which we can put onto this board. And this clock also needs to clock this board. That's clocking this board.
Are you scared or what?
No.
So this is how you apply the logic. So you understand QPSK? And you have sine and cosine.
If they did PSK last year, then they are fairly close to it. It's just this doubling up, and then having to clock this circuit here. That's extra to the PSK.
I only get that bit wrong, don't I? The last bit, I always... But it's actually applying what you've learned. You follow the steps. You see the block diagrams on the board? No, not on the board, not me. It's actually all broken down, nice sequentially. Right. You've got a volunteer to actually do it. Godfrey. Yes, could you do that now? You can shoot. You was here nice and early and bright. You can do this, can't you?
Not here. Maybe next week.
No, just look at the block diagrams. Sometimes
That's the trigger.
actually labelled up.
Something like this last year, right?
Yeah, so we get the oscilloscope locking onto the frames.
Two signals, yeah? You input signal, you divide it into Q, you modulate it. So again, these blue wires, yeah, as space, as air. So this is the transmitter of a radio station, and this is the receiver. So, right.
So does Jonathan set up every single
Julian.
Julian, sorry.
He can do. I think with this lot we might have to, but I'd like to see him. It'd be good if they can follow. If you can follow the logic, how QPSK works. It's easy.
This is the first day. This is the first week.
We need to do the grid tree.
The other thing I do not, you never ever connect the power supply though. Don't you with that? That's right. A few capacitors blown take sort of damage someone's eye last time. That was me poking him for doing it in his eye. On the report, right?
It's scary.
Yeah.
You can see it locked onto the signal here.
Go ahead.
It's going to be just green everywhere.
Bring the video. Let's use the video.